So in this video, we're going to start chapter 8, which talks about testing hypotheses. And before I get into some of the material, first I want to stress how important this concept is. Testing hypotheses is used a whole lot out in the real world. Whether it's in in industry or if you're doing research, and there's a whole lot of different concepts that go along with testing hypotheses. We're going to talk about a significant amount of those concepts, but we're not going to talk about every single aspect about testing hypotheses in this course. Also, once we get into some of these concepts, since there are so many different aspects to some of these concepts, some of the things that we're going to do are going to be unique to this class because we're going to try to limit the scope about what we're going to talk about for some of those concepts. If we get too deep down into some of those concepts, the questions that we would have to write would be super complicated and it'd have to contain a whole lot of details. So therefore, we're going to definitely touch on a whole lot of concepts when it comes to testing hypotheses, but there's also going to be some unique stuff that we do that are specific to this class to make sure that the questions that we can write to assess your understanding of those concepts are going to still be relatively straightforward to write and also to complete. So as I go through this information, I'll definitely point out the stuff where we're trimming off some of the information, where we might limit ourselves in our discussion for those concepts, and also where if you take a higher level stats course, if you go on and you try to dig a little bit deeper on these concepts, where there is definitely a lot of room to expand on some of these concepts that we're talking about. So that's the first thing. The second thing that I also want to point out here is this. When it comes to hypothesis testing, we're entering into a very, very important realm in statistics. And because of that, we're going to also have lots of new definitions in this chapter. So what this lecture video is going to be is it's going to be primarily lots of definitions, but we're also going to try to apply some of those definitions. But we're not going to do a whole lot of quote-unquote math stuff in this lecture video. What I'm going to try to do in this lecture video is go through, give some background information on these definitions, try to make sure that everybody's comfortable with these definitions. We're really introducing like a new language here, so we want to make sure that we're all speaking the same language. And then once we're comfortable with this stuff, we're going to go on and we're going to apply this to some math-related type questions. Or at least questions where we're going to be doing more math-related stuff. Now, as we're going to see once we get to those problems, a lot of stuff that we're going to do to solve those problems is really, really similar to what we did in Chapter 7. We're really just adding a couple of extra steps to what we did in Chapter 7, which dealt with estimation. We're going to look at it from a slightly different perspective, and we're going to add a couple of extra features to those things. But as long as you feel comfortable with Chapter 7, Chapter 8, after you get through like the vocabulary portion of it, Chapter 8 tends to be pretty simple for most people. So let's go ahead and start looking at some of these definitions. First off, what is a hypothesis? So here, these boxes, as I usually have in the notes, these are definitions that come straight from the textbook that we're using in this class. So, a hypothesis is a statement about a population parameter. And this is super, super, super important for you to remember that a hypothesis is always, always, always going to be about a population parameter. So a hypothesis is, the way that we use it here in statistics is actually very similar to the way that you probably use it in everyday English, A hypothesis in everyday English is just simply something that you believe to be true. It's something that you're guessing is accurate. Well, in statistics, what we're going to first do is that we're going to make sure that that statement that we're making is about some characteristic about the population. We're never ever going to make that statement about a sample statistic. Now, why would we not make it about a sample statistic? Well, again, if you remember, we usually try to take samples from a population in order to say something about the population. So we take our sample, we calculate out something from that sample, that's our statistic, and then we use our statistic to estimate the population parameter. So if we know what our statistic is, there's no sense in trying to make some statement about that statistic that we believe to be true, because we already know what is true about that statistic. We know it. But what we don't know is the characteristic about the population parameter. So therefore, any hypothesis that we make is always about the population parameter. The main population parameters that we're going to be making hypotheses about is the population mean, which, what is the symbol for the population mean that we use? It's mu, the Greek symbol mu. And the other parameter that we usually talk about in this chapter is the population proportion. And the symbol for the population proportion is P. So what we're going to restrict ourselves to in this class, and that's another unique feature about this class, is we're primarily only going to talk about the parameters mu and p. Obviously, there's all sorts of characteristics that we can talk about the population, right? We can talk about the population standard deviation, we can talk about the population median or the population mode. So all of those are parameters, but in this class we're going to primarily restrict ourselves to these two parameters. Alright, so let's get a little bit deeper on these hypotheses. And what we really have are two hypotheses. We have what's called a null hypothesis, and we have what's called an alternative hypothesis. And here the book provided definitions for those, so let's first read those over and then we'll talk about them. First, the null hypothesis, and the symbol that we're going to use for the null hypothesis is H, capital H, with a little 0 as the subscript. And this H with the little 0 as a subscript, we pronounce that H naught. H naught. So the null hypothesis, denoted by H naught, is the statement about the population parameter that is assumed to be true unless there's considerable, convincing evidence to the contrary. So the statement that you believe to be true, that's what we're going to use as our null hypothesis. Now for the alternative hypothesis, the symbol for the alternative hypothesis is a capital H with a subscript of A. So it's HA. It's a statement about the population parameter that is contrary to the null hypothesis and is accepted as true if there is convincing evidence in favor of it. So the null hypothesis is what we believe to be true, and the alternative hypothesis is contrary to the null hypothesis, and we're only going to accept the alternative hypothesis if there's convincing evidence in favor of it. So let's go through a quick and easy example of this. Also, it happens to be one of my favorite hypotheses. One of my favorite null hypotheses, and the statement that I believe to be true, is this. Every year, the Tar Heels are going to win the national championship in basketball. That's a statement that I believe to be true, and I'm always going to believe that to be true, unless there's convincing evidence to the contrary. So once they go to March Madness and they get kicked out of the tournament, I'm going to believe that they're going to win the national championship until the clock hits 0 on a game in March Madness for which they have the losing score. But that's my null hypothesis, that the Tar Heels are going to win the national championship in basketball every year. Let's take a look at the alternative hypothesis then for that statement. The alternative hypothesis is contrary to the null hypothesis. So that is that the Tar Heels are not going to win the national championship in basketball. And the only way that I'm going to accept this as true is if there's convincing evidence in favor of it. So if somebody says, hey, the Tar Heels are not going to win the national championship in basketball, that's contrary to the null hypothesis, so that's an alternative hypothesis. And the only way that I'm going to accept that as being true is if there's convincing evidence in favor of it. So again, if either the clock hits 0 on a game that they're on the losing end of in March Madness, or at the end of the season when there's a different team that has won the national championship. But here, I'm hoping that illustrates the difference between the null hypothesis and the alternative hypothesis, the one that you're believing to be true and the one that's contrary to it. All right, let's take a look at the testing of hypotheses. All right, so this definitions box is a little bit complicated. I'm going to talk my way through it, but if once we get through the end of this box, if it's as clear as mud, don't worry about it. We're going to revisit this later on once we start doing some numerical examples, but I want to at least talk our way through it one time. All right, so testing of hypothesis. It's a statistical procedure in which a choice is made between the null hypothesis and the alternative hypothesis based off of information in the sample. So we're going to make our hypothesis about a population parameter. Then we're going to take a sample, and based off of information that we're learning in this sample, we're going to determine whether or not we believe our hypothesis to be true or not. Right? Again, a quick and easy example of this one might be, as my null hypothesis, I believe that the average height of students at UNC Charlotte is 5 feet 11. So that's my null hypothesis. That's what I believe to be true, right? Now, what am I going to do to test my hypothesis? Well, I'm going to go out and I'm going to take a sample of students at UNCC. Maybe 200 or 300 students. And I'm going to take their heights, and I'm going to take the average of all of their heights, and then I'm going to come up with a number. Now, chances are, realistically, it's going to be somewhere that's less than 5'11", right? It might be something like 5'7". Well, if the sample average that I'm getting is 5'7" from like 300 students, and my hypothesis is that the average height is 5'11", chances are my hypothesis is going to be wrong. So I'm hoping that that quick and easy example is showing you the overarching picture of what we're going to do. We're using a statistical procedure to choose between the null hypothesis and an alternative hypothesis based off of information that we're getting in a sample. And our decision is this. For number one, if HA, and this is so extremely important right here, we're always going to focus on the alternative hypothesis. So even though the null hypothesis is a statement that we believe to be true, we're going to say that if the alternative hypothesis has the form that mu is strictly less than mu naught, and mu naught is the value that we're using for our alternative hypothesis, then we're going to reject the null hypothesis if the sample average is far to the left of mu naught. So here, the important thing is this. The way that these testing procedures, and these are coming straight out of your textbook. I didn't write these up. These are coming straight out of your textbook. We're focusing on testing or making our statement about the population mean. So therefore, the statistic that we're using is the sample mean. So we're going to use the sample mean to test our hypothesis about the population mean, just like we would use our sample sample proportion to test our hypothesis about the population proportion. So here these are written up in terms of dealing with the population mean. But if our sample mean is far to the left of the value that we're using for our hypothesis, then we're going to reject our null hypothesis. If our alternative hypothesis is written in such a way that mu is less than mu naught. For number 2, if the alternative hypothesis, and again we're focusing here on the alternative hypothesis, if the alternative hypothesis has the form that mu is strictly greater than the value from our hypothesis, then we're going to reject the null hypothesis if our sample average is far to the right of the value from our hypotheses. And lastly, if our alternative hypothesis has the form that mu is not equal to the value from our hypothesis, then we're going to reject the null hypothesis if our sample mean is far away from our value from our hypothesis in either direction. Alright, so I'm sure talking over that for the first time, I'm sure a lot of that probably didn't make sense to you at all. But I want you to take this away from this. If you can just take this away, for now, you're going to be on good footing. And that's this. We're determining whether or not we're rejecting our null hypothesis based off of the statement from our alternative hypothesis. So that we're always either rejecting or not rejecting the null hypothesis. But what we're using to determine whether or not we're going to reject or not reject the null hypothesis is based off of our alternative hypothesis. If you just take that away, that we're doing two things. One, we're either going to reject or not reject the null hypothesis. We're always only going to reject or not reject the null hypothesis. That's number one. Number two, we're going to use the alternative hypothesis to determine whether or not we're going to reject the null hypothesis. So we're going to look at our alternative hypothesis. We're going to do some stats and math to it. We're going to look at the alternative hypothesis in order to determine whether or not we're going to reject the null hypothesis. If that's the only thing you're taking away with that so far, you're good to go. We're going to keep backtracking to this definitions box. And later on, once we start doing numerical examples, it's going to become a lot clearer. Alright. So now let's take a look at these hypothesis statements. We have a general idea of what a hypothesis is. We have a general idea that there's really two hypotheses, a null hypothesis and an alternative hypothesis. And one we believe to be true, and the other one is the contrary to it. Then we know that we're going to be testing the hypotheses, and we're going to either reject or not reject the null hypothesis, and we're going to use the alternative hypothesis to determine whether or not we reject or not reject our hypothesis. But here's the thing. How do we write these hypotheses? And here, this is a general guide of how we're going to write the null and the alternative hypotheses. And this general guide is extremely, extremely, extremely important. Because what this is going to allow us to do is take some phrase and write it in terms of math symbols. And that's going to be our first step in applying math and stats concepts to these phrases. So that's why this step is extremely important, right? How do you take a phrase that says the Tar Heels are going to win the national championship, and how do you take that phrase and put it into math symbols? How do you take the phrase, I believe that the average height of all students at UNCC is 5'11"? How do you take that statement and put it into math symbols so that we can start doing math stuff to it to determine whether or not we're right or wrong? And that's what we're doing right here. Now, keep in mind that some of these concepts right here are, again, unique to this class. And which ones and why they're unique to this class, I'll highlight as we go through this box. So here it says, the problems in this course adhere to the following simplifying guidelines. The guidelines are not universally applicable outside of this course, but what we're going to first do is we're going to apply these concepts, these guidelines. We're going to become familiar of how to write these things. And once we're familiar with that, we'll take the next step. But the next step is going to be the next course. So these guidelines apply to this course. So again, number one, the null hypothesis must always contain an equality sign. So our null hypothesis must contain one of these three symbols: greater than or equal to, less than or equal to, or equal to. That's not a smiley face, right? Here I'm closing this bracket. It'd be pretty sweet if we had a smiley face in our hypothesis. It'd probably be like the best hypothesis ever. But that's not a smiley face, right? It's an equality sign, greater than or equal to, less than or equal to, or exactly equal to. Our null hypothesis must contain one of these. The alternative hypothesis will never contain equality. It's either going to be strictly greater than, strictly less than, or strictly not equal to. Those are going to be the only symbols that we're ever going to have in our alternative hypothesis. That's extremely, extremely, extremely important. If you have a symbol that has equality in it, in your alternative hypothesis is wrong. If you have a null hypothesis that contains one of these three symbols, strictly greater than, strictly less than, or strictly not equal to, your null hypothesis is wrong. These are the only symbols that you can use for the null hypothesis. And these are the only symbols that you can use for the alternative hypothesis. Alright, number 3. If a particular problem gives us the null hypothesis, but not the alternative hypothesis, we may use the complement of the null hypothesis as the alternative hypothesis. So here, if a particular problem gives us the null hypothesis, but we don't have the alternative hypothesis. So if it only gives us one statement, but not the other, only the null, not the alternative, then we can use the complement of the null hypothesis as the alternative. Because we must always have the null and the alternative hypotheses in every single problem that we do. We must have both parts. It's like two sides to a coin. You can kind of imagine that, right? Every analogy limps in a certain way. But you can imagine that the null and the alternative hypothesis is two sides to a coin. you always have to have the whole coin. So therefore, you have to have both sides of it. So therefore, if a problem only gives us one side of the coin, the null hypothesis, we can use the complement of the null in order to determine what the other side of that coin is, the alternative hypothesis. For number 4, however, if a particular problem gives us the alternative hypothesis, so instead of getting the null now, we're only given the alternative, but not the null hypothesis, we can use one of two things. We can either use the complement of the null hypothesis we can either use the complement of the alternative hypothesis as the null hypothesis, or we can use strict equality equals to as the null hypothesis. So, to be specific about this, your textbook, or the textbook that I've taken these definitions from, the textbook that the department recommends for this course, always uses equality for the null hypothesis. But the questions on your homework, on your in-class exams, and on your final exams use these 3 symbols for the null hypothesis. So therefore, keep in mind that your textbook primarily just uses B, but your in-class exams, your homework, and your final exam uses both A and B. So if you're following along in the textbook, I just wanted to point that out. Some of you are, right? Again, the textbook is optional for this class. So therefore, keep in mind that if you're following along with the textbook doesn't have a whole lot of examples for 4A, but it has a lot of examples for 4B. All right, let's practice writing some of these hypotheses. Since this is going to be the first step in taking some English sentence and putting it into math symbols, that's a huge first step. We want to make sure that we get the first step right. So let's practice doing this first step. So these are examples of the null and alternative hypotheses. State the null and alternative hypothesis for each of the following. The average temperature in July in Charlotte, North Carolina has historically been 81.3 degrees Fahrenheit. Perhaps it is higher now. Alright, so what we're going to do for all of these questions is we're going to write down the null and the alternative hypotheses. Again, the null hypothesis is H0, and the alternative hypothesis is HA. We're going to primarily ask ourselves 3 questions whenever we try to figure out what the null and the alternative hypothesis are. The first question that we're going to ask ourselves, and I'm going to write these up here, is question number 1 is there a statement that contains equality? Is there a statement which contains equality? And if there is one, that's going to become our null hypothesis. Because remember that our null hypothesis must contain an equality symbol. So the first thing that we're going to do is figure out, do we have a statement that has equality in it? So we're looking for greater than or equal to, less than or equal to, or exactly equal to, or some English statement that is equivalent to that, right? So you might not always have something that says that this is equals to. It might say something like that it just is, or the value is this, or something like that. So let's take a look. The average temperature in Charlotte, North Carolina has historically been 81.3 degrees Fahrenheit. Perhaps it is higher now. Do we have a statement which contains equality? And the answer to that question is yes. That this temperature has been 81.3 degrees Fahrenheit. Has been 81.3 degrees Fahrenheit. We could say that the temperature has been equals to 81.3 degrees Fahrenheit. And we'd be saying the same thing. So therefore, it does contain a statement that has equality. So therefore, it's going to become our null hypothesis. And the equality symbol that we have is equals to. So therefore, our null hypothesis is going to become equals to 81.3 degrees Fahrenheit. And I'm leaving myself a little bit of space here on purpose because we're going to go back and fill in that portion. So the first statement that we ask ourselves, or the first question that we ask ourselves is there a statement which contains equality? We answered yes to that. So therefore, that becomes our null hypothesis. The equality symbol that we have is equals to, so that's why we're using equals to right here with 81.3 degrees Fahrenheit. The second question that we're going to ask ourselves is there a statement that does not contain equality? And if there is such a statement, that's going to become our alternative hypothesis. So the first one that we're asking ourselves is there a statement which contains equality? Probably is a better English way of writing that there shouldn't be that, there should be which, I think. Gosh, I don't know why I took a quick tangent there into English grammar. But anyways, the first one that we're asking ourselves here is that, is there equality? The second question that we're asking ourselves is there a statement which does not contain equality? So again, strictly greater than, strictly less than, or strictly not equal to is what we're looking for now. And if we have such a statement, then that's going to become our alternative hypothesis. So, we do have such a statement, and it says, perhaps it is higher now. Perhaps the temperature is higher, which means that perhaps the temperature is greater now. So, the symbol that we're going to use for this then is greater than 81.3 degrees Fahrenheit. So again, because we had a statement which does not contain equality, that becomes our alternative hypothesis. The symbol that we're having is strictly greater than. So therefore, strictly greater than 81.3 degrees Fahrenheit becomes our alternative hypothesis. The third question that we're going to ask ourselves is, what is the parameter of interest? What's our parameter of interest? What's the parameter that we're interested in? Again, for this class, and again this is unique to this class, the two parameters that we're primarily interested in for our hypotheses is either going to be mu or p. If we're talking about some average, we're dealing with mu. We're dealing with some proportion or a fraction or a percentage, we're dealing with p. So here we're talking about the average temperature. So therefore the parameter that we're interested in is mu. And that's what we're going to write right here. If we determine that we were dealing with some proportion, then we would have written P where we just wrote the symbol mu. And here we have it. We've written our first null and alternative hypothesis for chapter 8. Alright, so a couple of things about this here. We have our null hypothesis, and our null hypothesis contains equality. we have our alternative hypothesis, and our alternative hypothesis contains a symbol that does not have equality. And what I want to point out here too is a couple of things. It's really, really, really important that we're writing our hypotheses as our parameter. Then next, we have some math symbol. And then next, we have some number. We have our parameter, then some math symbol, and then a number. We're going to follow that convention for the rest of this class. And that's a very, very standard convention to have even outside of this class. But I want to point it out here because what I'm going to do later on is I'm going to show you some shortcuts that you can use whenever you do subsequent steps in a hypothesis testing, right? All that we're doing so far right now is just writing down the null and alternative hypothesis. We still have to go through and test these to see which ones, or whether or not we're going to reject or not reject the null hypothesis. And there's some easy shortcuts that I've come up with, but the shortcuts only work if we've written our null and alternative hypothesis in this format. Parameter, math symbol, and then some number. Alright, let's go on to number 2. And what I recommend that you do is pause the video, give this a chance by yourself, try to write down the null and the alternative hypotheses, and then start the video to see if you got it right. One last thing before we go on to number 2 is this. And here's a shortcut. Sometimes this shortcut works, sometimes it doesn't, but it's going to kind of help out a little bit. And that's this. Whenever you're going through these questions, especially question number 1 and 2, to see if there's a statement which contains equality and one that doesn't, when we first ask ourselves, is there a statement which contains equality, we notice that this first statement right here did contain equality. A shortcut is this. If you have already used a statement and you've determined it contains equality, you can think of that statement as being used up. Typically speaking, we're not going to try to cram both the null and the alternative hypothesis into one sentence. That's just a general rule, right? They might start getting fancy with adding commas and, having 2 of them. But generally speaking, if you've used up one sentence, generally speaking, you can focus on the other sentences to see whether or not those other sentences have stuff that you're looking for. Alright, so let's go on to number 2 now. Number 2 says, the average weight of a newborn puppy is no more than 15 pounds. Again, we're trying to write our null and our alternative hypotheses. First question that we're going to ask ourselves is there a statement which contains equality? The average weight of a newborn puppy is no more than 15 pounds. So a puppy can be less than 15 pounds, but it can also be exactly equal to 15 pounds. So therefore, this puppy's weight has to be less than or equals to 15 pounds in order to be no more than 15 pounds. And less than or equals to 15 pounds is a statement which contains equality. So therefore, that's going to become our null hypothesis. So we're going to have less than or equals to 15 pounds as our null hypothesis. The second question that we're going to ask ourselves is there a statement which does not contain equality? Well, like I just got done saying, we've already used this up. There is no other statement other than the one that we just read. So therefore, here, we're getting to this case now where we have the null hypothesis, but we do not have an alternative hypothesis. So what do? If a particular problem gives us a null hypothesis, but not the alternative hypothesis, that's the situation that we currently find ourselves in, we may use the complement of the null hypothesis as the alternative hypothesis. So we want to use the complement of the null as the alternative. So what's the complement? Remember now back to chapter 3. We talked about complements. Right? In chapter 3, we had these Venn diagrams. We said that we had an event A. What's the complement of event A? Everything inside our sample space other than A. So all this stuff that I just shaded in right here, that's the complement to A. So everything that's not contained in here is contained in the complement. So therefore the complement is strictly greater than 15 pounds. So if our null hypothesis is given to us and our null hypothesis is less than or equal to 15 pounds, then the complement is going to become our alternative hypothesis, since we weren't given an alternative hypothesis, which is strictly greater than 15 pounds. Now, the last question that we're going to ask ourselves is, what is our parameter of interest? And here we're talking about the average weight. So therefore, again, mu is the parameter that we're interested in. Alright, and now we have our second null and alternative hypothesis for chapter 8, which brings us again to another really important concept and something I haven't mentioned yet, but maybe something that you're starting to pick up on. The number that we have for the null hypothesis must always be the same as the number that we're using for our alternative hypothesis. If we have 15 pounds here, we have to have 15 pounds here. The number must always be the same. If we have 81.3 degrees Fahrenheit here, we have to have 81.3 degrees Fahrenheit here. I'm going to say that over and over and over again, because as we get into more complicated stuff, sometimes people will try to have like 15.1 here or 15.01 here, or here they'll try to have 81.4 degrees or something like that. Don't get into that rabbit hole. Don't go down that rabbit hole. Whatever number you have here has to be the same number as you have in your alternative hypothesis. Now, technically speaking, that's just unique to this class. If you get into more complicated stuff for alternative hypothesis and null hypothesis, if you're dealing with complicated situations, technically speaking, that doesn't always have to be the case. But the scenarios that we're going to restrict ourselves to here in this class is that these numbers always must be the same. So, more specifically, in this class, if these numbers are not the same for you, that's wrong. So if you ever come across an answer choice where these two numbers are different, you can immediately make the conclusion that that answer choice is incorrect. Alright, let's go on to number 3. Again, try to pause the lecture video and see if you can do number 3 by yourself. The average stipend for mathematics doctoral students at state universities in North Carolina is believed to be $14,756. One of the department chairs at these schools believes that the national average is lower. Here again, we're trying to write our null and our alternative hypotheses. The first question that we ask ourselves whenever we're trying to write the null and the alternative is there a statement which contains equality? And yes, we do have such a statement here. It says that the average stipend for mathematics doctoral students at state universities in North Carolina is believed to be $14,756. So the math symbol that we have for that is equals to, therefore it becomes our null hypothesis, and it's equal to $14,756. The second question that we're going to ask ourselves is there a statement that does not contain equality? We can think that we already used up this first sentence. So the only sentence that we have left over is one of the department chairs at these schools believes that the national average is lower or less than. So strictly less than is going to become our alternative hypothesis. And then therefore these numbers must always be the same. So we're going to have strictly less than $14,756. Number 3, what is the parameter of interest? We're talking about an average here, so therefore we're dealing with mu's, not proportions. And here we have the null and the alternative hypothesis for number 3. Again, we're following the same concepts that we have in all of these previous examples. Parameter, math symbol, number. Equality only in the null hypothesis. Inequality or strict inequality in the alternative hypothesis. The numbers are the same, and so on and so forth. All right, let's go on to number 4. An economist states that the average salaries of statisticians in North Carolina is at least $150,000. A random sample of 80 statisticians from Charlotte, North Carolina is selected with a mean of 163,000 and a standard deviation of 8,200. We're trying to write down the null and the alternative hypotheses. So therefore, what's the first question that we're going to ask ourselves? Haha. I moved the piece of paper up, so I covered up what the question is. Try to remember the first question off the top of your head. What's the first question that we're going to try to ask ourselves? First question we're going to ask ourselves is there a statement which contains equality? So we're looking for equals to, greater than or equals to, or less than or equal to. And here it says in the first sentence that an economist states that the average salary of statisticians in Charlotte, North Carolina is at least $150,000. So it can be equals to $150,000, but it can also be greater than that. So therefore we have greater than or equals to $150,000. It's at least $150,000. Alright. The second question that we're going to ask ourselves then is what? Is there a statement which does not contain equality? We've used up this first sentence, so let's take a look at the second sentence. A random sample of 80 statisticians from Charlotte, North Carolina is selected with a mean of $163,000 and a standard deviation of $8,200. Does that statement contain something that does not have equality in it? Well, let's take a really, really close look at this statement. First off, are we talking about the population in this sentence, or are we talking about a sample? And here we're talking about a random sample. Remember that our hypotheses must always be about a population parameter. We're always talking about our populations when we're looking for our hypotheses. This statement is not talking about the population. The statement is talking about a sample. So therefore, this statement cannot be a hypothesis. So that's our first indication that this statement is not about a hypothesis. Another thing that's giving it away is we know our hypothesis has to have the number 150,000 in it. Here we have 163,000 and 8,200. We cannot have different numbers here. We have to have the same number. So that's another indication that this second sentence has nothing to do with our hypothesis. So we're not going to use this second sentence. The second sentence is giving us other information that we do not need to write our hypothesis. So therefore, all of the information that we're given, we only have our null hypothesis. If we only have a null hypothesis and we're not given the alternative hypothesis, what do we use to write the alternative hypothesis? The complement of the null hypothesis, right? Going back to our definition here again, if a particular problem gives us the null hypothesis but not the alternative hypothesis, we may use the complement of the null hypothesis as the alternative. So therefore, the complement is going to be strictly less than $150,000. All right, and lastly, the third question that we ask ourselves is what? What is our parameter of interest? And here we're dealing with the average salary. So again, the parameter that we're interested in is mu. All right, so here for number 4, let me say something else. We have this additional information here that we never use in our second sentence. And the reason why I've done this is this. The next steps that we're going to learn how to do is to test our hypothesis. Again, eventually we want to get to the fact of where we either reject or not reject the null hypothesis. In order to be able to reject or not reject our null hypothesis, we're going to have to do additional steps, additional calculations. For those additional steps and additional calculations, we need to know information like we have in the second sentence. So what I'm going to try to start to get you used to is to look past this additional information in order to be able to complete the first step in writing the null and the alternative hypothesis. And then recognize the additional information is going to go in the next subsequent steps when we go and start testing these hypotheses. But for our first step, we need to be able to look past this additional information that we're going to need in subsequent steps. All right, let's look at number 5. The average height of all students at UNCC is believed to be less than 6 feet. All right, let's look. We're trying to write the null and the alternative hypothesis, so we have H naught and HA. The first question we ask ourselves in writing the null hypothesis and the alternative hypothesis is there a statement which contains equality? We're looking for greater than or equal to, less than or equal to, or exactly equal to. Well, here we just have less than. That's not less than or equal to. So therefore, we do not have a statement which contains equality. The second question then that we ask ourselves is there a statement which does not contain equality? Strictly less than, strictly greater than, or strictly not equal to. And like I just said, we have that. So we have that it's strictly less than 6 feet. So therefore, that's going to become our alternative hypothesis. And that's the only information that we're given. So how do we figure out our null hypothesis? That's where we get to number 4. If a particular problem gives us the alternative hypothesis, but not the null hypothesis, that's the situation which we currently find ourselves in, we may use one or the other. Either A, where we can use the complement of the alternative hypothesis as the null hypothesis, or we can use strict equality, the equal sign, as a null hypothesis. So therefore, we can either use the complement as the null hypothesis, and the complement of strictly less than is greater than or equal to 6 feet. Again, these numbers must be the same. Or it's telling us here that what we could also do for B is telling us that we can also use equals to as the null hypothesis. So therefore, this can be equals to 6 feet. So both of these hypotheses, both set of hypotheses, are technically speaking correct for our course. Right? So if we're only given the alternative and we're not given the null hypothesis, we can use either one of these symbols as the null hypothesis. Alright, so let's finish off this problem. I'm going to say something else about number 5. Because the last question that we need to ask ourselves is, what is our parameter of interest? And again, here we're dealing with the average, so therefore the symbol that we're going to use is mu. Alright, so let's talk about number 5 here for a second. Both of these symbols for our null hypothesis is correct for our course. So therefore, what you're never going to see is this. Well, let me first talk about what you are going to see. You are going to see problems that are going to ask you to write the null and the alternative hypotheses for a particular statement. That is something you are going to see. What you're not going to see is then that this could be like answer choice A and this would be answer choice B. You're never going to see that, because otherwise you have two possible answer choices which are both technically correct for this course. So therefore you're either going to see one of these or the other one. You're never going to see both of these answer choices. But keep in mind that either one of these answer choices are possible solutions to this problem. Alright, let's go on to number 6. Again, try to pause the video and try to do this one by yourself. The average home price in Charlotte, North Carolina is rising quickly. It is believed to be above $200,000. A random sample of 349 homes is selected, which had a mean price of $213,400 and a standard deviation of $7,940. We're trying to write the null and the alternative hypothesis for both for this problem. So H0 and HA. And the three questions that we ask ourselves are, is there a statement which contains equality? Do we have such a statement here? Well, the average home price is rising quickly. That doesn't give us an equality. It is believed to be above $200,000. It's above something, so it's strictly greater than it. So that doesn't contain equality. But here, we'll keep this one in mind for our alternative hypothesis. And here, a random sample of 349 homes has this mean and this standard deviation. Here we're again talking about a sample, so therefore we cannot use this statement for our hypothesis because our hypothesis only talks about parameters. So therefore we do not have a statement which contains equality. But our second question of, is there a statement which does not contain equality? We do have that one. Like I pointed out, we'll keep this one for our alternative hypothesis. and it's strictly greater than $200,000 since it needs to be above $200,000. So just like in question number 5, we have an alternative hypothesis, but we do not have a null hypothesis. So therefore, what do we use for our null hypothesis? We can either use the complement of our alternative hypothesis, and now the complement is less than or equals to $200,000, or we can also use strictly equals to for our null hypothesis. So again, either one of these is a correct answer for this class. Now, to finish off this problem, we're going to ask ourselves our third question. The third question is, what is our parameter of interest? And our parameter of interest is, we're still dealing with the average, so here we're still using mu. I'm hoping that writing down the null and the alternative hypothesis is becoming easier for you. We haven't done an example here that's dealing with proportions, but rest assured we'll get into proportions later on, and the only thing that would ever change is it would say something like the proportion of home prices, or the proportion of heights, or the proportion of salaries, and then we would simply just use P instead of where we use mu. But we'll have plenty of examples later on for that. Right now, we're just trying to get used to writing down the null and alternative, and I'm hoping that going through these examples helped you with this very, very important box right here of how to exactly take phrases and write them in terms of math symbols. Because what we're going to do next is figure out how to take those math symbols and test to see whether or not we're going to reject our null hypothesis, or whether we're not going to reject our null hypothesis. But we'll save that for the next lecture video. For now, we'll call this quits, and we'll pick up here next time.